In section 6.4, we'll cover how to take nth roots of different polynomials, such as square roots, cube roots, fourth roots, and so on. Now let's start with one that we're already familiar with. We have the square root of 25x to the 12th. First thing to realize is that anytime that we see a square root, we can rewrite it as something to the 1/2 power. Okay, now you want to recognize these as the same thing. So anytime you see something raised to the 1/2 power, it means we're taking the square root of it. And anytime we're taking the square root of something, we're really raising it to the 1/2 power. Okay, this plus minus out front just means we're going to keep a plus minus in the problem and carry it through to our answer. So first thing we'll do is break down this 25 into a factor tree. We get 5 and 5. Since we have a pair of 5s here, we know that means that we're going to have a 5 in our answer that moves outside that radical sign. Let's do the same thing with these x's. Since it's x to the 12th, that means we have 12 x's, and every pair of x's moves to 1 x on the outside. So if we look at it this way, we have 6 pairs of x's, which means we're going to have x to the 6th power. 6x is outside that square root, nothing left on the inside. If we treated it as an exponent rule problem, okay, we would multiply those exponents, x to the 12th raised to the 1/2 power, multiply them, gives us x to the 6th. 25 to the 1/2 power is square rooted. Square root of 25 is 5. Keep that plus minus out front. All right, number 2. Now instead of doing a square root, we're doing a cube root, which means instead of having 2 of the same thing to move it outside, we need to have 3 of the same thing. So for this, x to the 6th, for every 3 x's that we have, we're going to move one of these x's outside. Okay, so we have 6 x's, which means we have one group of 3 and a second group of 3. That's going to be x squared moves to the outside of that cube root. Okay, same thing with the y's. There's 6 groups of 3 y's and y to the 18th. Okay, the other way we could write this is just like we did up here. Okay, cube root is to the 1/3 power, and we can just treat this as a multiplication problem, and we'd get that same answer. 2 groups of 3 x's, 6 groups of 3 y's, or just multiply those exponents to get x squared y to the 6th. All right, number 3, fourth root this time. We have x plus 3 inside the parentheses to the 12th power. We really have x plus 3 times itself 12 times, right? So it would look like that, okay? Just like these other ones, fourth root means it's to the 1/4 power, okay? And just like before, we're going to multiply those exponents, and it's just going to go to that 12. It's not going to go to everything on the inside, okay? We just multiply those exponents. Reason being is if we have 12 of these same parentheses, and we're taking a fourth root, every 4 of them means we get 1 on the outside. So here's 1, here's a second one, here's a third one. Okay, so we had x plus 3 cubed. Keep this negative sign since it's out front. So that's really the idea. Anytime we're taking a root that's not a square root, we just look at this number. That's how many items we need to move one of them to the outside. So for example, 32, we're going to do a factor tree. Okay, let's start by saying 16 and 2. 16 we can break down further. It's 4 and 4. And then both of these 4s we can break down to 2 and 2. Okay, so at the bottom of our factor tree, we have 2 to the 5th power. We have 5 2's here. Okay, that's convenient because we're taking the 5th root of 2 to the 5th power. And then we also have this other stuff over here. Now, also keep in mind, the 5th root is the 1/5 power. Okay, so we really can put this in parentheses and raise it to the 1/5 power. It's the same as just multiplying all these exponents by 1/5. So 2 to the 5th power, taking the 5th root, is just going to be 2. Okay, we have 5 2's here. The 5th root of 5 2's is just 2. These exponents are going to get multiplied by 1/5, and it gives us our answer 2a to the 8th, 40 times 1/5, b to the 20th, 100 times 1/5. All right, next one, fourth root of 81, x to the 16th, y to the 48th. Break down that 81, 9 and 9. Okay, again, we get a bunch of 3's. 4 3's, 3 to the 4th power. We're taking the 4th root of this along with all this other stuff. Okay, distribute that in. We're going to multiply those exponents. We have the fourth root of 3 to the fourth. We end up with plus minus 3x to the fourth y to the 12th. Lastly, this one has a negative inside the radical sign, so this is going to have an I. It's a square root, so this is like all the other ones that we've done. Okay, so break it down. We have 2 6's. That's going to move to the outside along with an I. All right, and then just keep in mind that when we're taking the square root of exponents, we're not square rooting the 4 and square rooting the 16. We're taking half of them. Okay, so we end up with 6i x squared y to the 8th, because when we do y to the 8th squared, for example, we multiply those exponents. That's what would give us that 16th power. Two last ones just to really drill it home. Negative fourth root 16 parentheses x to the fourth minus 2 raised to the 12th power. Break down that 16, we get 4 and 4. Break them down again, we have a bunch of 2's. Okay, put that in the parentheses as 2 to the 4th power, along with that other parenthesis of x to the 4th minus 2 to the 12th power. Now keep in mind when we have an exponent on the outside, so I've changed this 4 to a 1/4 power, okay, and it's just going to the two things that are multiplied. We're not sending it, we would send this 12 to everything inside the parentheses, okay, but these things on the outside here is going to these two things that are multiplied. It doesn't go inside that individual parenthesis. Okay, so we have the fourth root of 2 to the 4th, that's going to be 2, and the fourth root of this guy, which is going to be that guy, to the 3rd power, because we're just going to multiply these exponents. All right, so negative 2 x to the 4th minus 2 cubed. Last one in the notes for this section, 6th root of 64 x to the 12th y to the 30th z to the 6th. I think you guys get it at this point. Break down the 64 all the way till we have the factor tree fully broken down. Okay. Keep note that anything that's broken down isn't part of our factor tree, so we just have the bottom leaves of the tree that we look at. So we have 2 to the 6th power. Okay, along with all those variables, this is to the 1/6 power because it's the 6th root. Okay, this goes to everything inside here. And our answer, 2x squared y to the 5th z.